Picture this, a field of stars so deep, so ancient, that every pixel in the image holds a story older than time itself. You zoom in, and there, between familiar galaxies, are these faint crimson specks. They don't spiral, they don't stretch, they just glow. Astronomers call them little red dots, and, some of them might be black holes pretending to be stars. Welcome to Cosmic Origins Revealed, where we trace the universe's biggest mysteries back to their source. This episode is all science verified and full sources linked below. It's late at the Max Planck Institute in Heidelberg. On a monitor, fresh JWST data scrolls across the screen. Columns of numbers, each representing ancient light. Postdoc Raphael Hviding leans closer, squints, and half-jokingly says, "Another red dot." But this one looks different. Its light peaks sharply in the infrared, dips in the middle, then climbs again toward the ultraviolet. That V-shape means something is happening, something energetic, compact, and fast. A few months later, that same dot will appear in a new catalog called RUBIES, Red Unknowns Bright Infrared Extragalactic Survey 2025. It's part of a huge effort, more than 4,400 galaxies analyzed with JWST's NIR spec, spanning billions of years of cosmic history. About 1,500 lie beyond redshift 3.1, light from over 11 billion years ago, and 80 of them show unmistakably broad Balmer lines, the fingerprints of swirling gas around active black holes, RUBIES 2025. Well, the name says it all, right? They're little because each one is smaller than roughly 500 parsecs, about a tenth the size of our galaxy's core. They're red, glowing brightest in infrared light, the kind JWST was built to catch, and they're dots, because even with Webb's precision, they stay unresolved, single bright points adrift in darkness. Now, that redness could come from dust or from very old stars, but spectroscopy shows something else lurking beneath: fast-moving gas, high-energy photons, and the kind of heat only gravity itself can make. When the RUBIES team compared spectra, they noticed three repeating clues: broad Balmer lines, that striking V-shaped continuum, and a point-like structure. When all three appear together, there's, a pretty good chance you're seeing a black hole at work. Out of the 1,000 examined, 36 objects tick all those boxes. Let's take just one, RUBIES EGS 42046. It sits more than 13 billion light-years away, so far that its light began its journey when the universe was barely a billion years old. The data show an incredibly broad H-alpha line, gas whipping around a massive core at thousands of kilometers per second. There's no visible galaxy structure, no extended halo, just that single red pulse of energy. So, in all likelihood, this little dot marks one of the earliest active black holes ever observed. And that's, honestly, goosebump material. Try picturing this. If you held out your hand toward the night sky, one of these red dots would fit comfortably behind a single grain of sand balanced on your fingertip. Yet, inside that tiny pixel of light might live a black hole millions of times the mass of our sun, feeding on gas, shaping its host galaxy, and sending light that travels billions of years just to reach your eyes tonight. Kind of humbling, right? Now, here's where things start to bend our understanding. If all these little red dots really host black holes, there are too many of them, at least 10 times more than predicted by existing simulations, RUBIES Section 5. That's not a rounding error. That's a fundamental puzzle. It suggests black holes didn't need much time to form after the Big Bang. They appeared quickly, maybe through direct collapse gas clouds, skipping the star stage entirely, or by accreting matter at phenomenal rates. Either way, something in our timeline doesn't add up. RUBIES doesn't claim to solve that. It simply shows the evidence and leaves the debate open. And that honesty, I think, is what makes it exciting science. Of course, other researchers have their own ideas. Some think these dots are extreme starburst galaxies, where stars form so rapidly that their combined light mimics an active nucleus. Others blame dust for reddening the signal, or even point to brown dwarfs in our own galaxy that could fool JWST's filters. The RUBIES team checked each scenario, and while a few objects might fit those alternatives, most of the broadline sources just can't be explained that way. So, while the debate continues, the simplest explanation, active black holes, still fits best. Then, in 2025, another study stirred the pot. A group led by researchers at the University of Portsmouth proposed something radical. Maybe these aren't galaxies at all, but black hole stars, massive hybrid objects where a black hole sits inside a luminous stellar envelope. Imagine that, a black hole wrapped in its own light. The idea is mesmerizing, but, still hypothetical. No direct observation yet confirms such an object. Even the RUBIES authors emphasize that while their spectra are consistent with accreting black holes, they don't prove any new class of stars. Still, the possibility has the field buzzing, because if even one of those dots turned out to be a true black hole star, it would change how we think about the very first luminous objects in the cosmos. If massive black holes were already thriving when the universe was under 1 billion years old, then galaxies and black holes must have co-evolved from the start. They weren't separate stories, they were kind of chapters of the same cosmic book. You can almost picture it. While matter cooled and stars first ignited, tiny gravitational wells were already pulling their neighborhoods together. Those early black holes might have been, in a sense, the seeds of everything we see today. So instead of black holes being cosmic destroyers, they might have been the first architects. That's a pretty beautiful twist. And behind all of this, behind the data, the press releases, the debates, are real people staring at their monitors at 2 in the morning. Raphael Hviding, Anna de Graaf, Jenny Green, Casper Schultz, dozens more. Each spectrum they plot is a handshake across 13 billion years. When I spoke with one of them, off record, over coffee, they said, "The hardest part isn't finding the signal. It's accepting that it's real." That's the emotional weight of working on the frontier. Every new spectrum feels like the universe whispering, "You're getting warmer." Future JWST programs, especially using MIRI and NIRSpec again, will target these LRDs with longer exposures to test their mid-infrared signatures, chemical makeup, and any subtle flickering that might betray an accreting black hole's heartbeat. Meanwhile, Earth-based giants like Keck and the Very Large Telescope are sharpening redshift measurements and estimating host masses. If these results hold, we'll soon map how common early black holes really were, and maybe how they helped sculpt the first galaxies. And if not, well, we'll still have uncovered one of the strangest optical illusions in the universe. So the next time you see one of JWST's deep field images with all those tiny red sparks scattered across black space, pause for a second. Each one is a story frozen in time, a message from an era when light itself was young. Some of those dots are ordinary galaxies, sure, but a few, maybe the most intriguing few, are black holes hiding in plain sight. They remind us that even at the dawn of creation, the universe already knew how to keep a secret. If you enjoyed today's journey through cosmic origins revealed, maybe follow or subscribe for more deep space stories, each one fully science verified and told with a human touch.